Determination of concentration of KMnO4 solution using oxalic acid. Titration is a common laboratory technique used to determine the unknown concentration of a given solution. In this titration, the strength of the given potassium permanganate is determined by titrating it against standard solution of oxalic acid. In the reaction between potassium permanganate and oxalic acid, permanganate ion is reduced to manganese 2 ion in the acidic medium and oxalate ion is oxidized to carbon dioxide. Our aim here is to determine the concentration of a given potassium permanganate solution by titrating it against standard solution of oxalic acid. Materials required: oxalic acid crystals, potassium permanganate solution, dilute sulfuric acid, distilled water, electronic balance, weighing bottle, spatula, 250 ml beaker, 250 ml standard flask, 250 ml conical flask, glass rod, funnel, test tube, dropper, 50 ml burette, burette stand, 20 ml pipette and hot plate. Procedure: preparation of 250 ml 0.1 molar standard solution of oxalic acid. The weight of a solute required to prepare a standard solution is equal to the molarity of the solution into molecular mass of the solute into volume of the solution in liters. Here, molarity of the solution is 0.1 molar. Molecular mass of the solute oxalic acid is 126 grams per mole. Volume of the solution is equal to 250 ml, that is equal to 0.25 liters. Therefore, the weight of oxalic acid required is equal to 0.1 into 126 into 0.25, that is equal to 3.15 grams. Place the weighing bottle on the electronic balance and tare the balance. Using the spatula, take oxalic acid crystals and transfer them into the weighing bottle and weigh 3.15 grams. Transfer the weighed quantity of oxalic acid into the 250 ml beaker. Wash the weighing bottle 2 or 3 times with distilled water to transfer the particles sticking to it into the beaker. Dissolve oxalic acid crystals in the beaker by gentle stirring with a clean glass rod. Using the funnel and the glass rod, transfer the entire solution from the beaker into the 250 ml standard flask. Wash the beaker, glass rod, funnel and funnel tip 2 or 3 times with distilled water to be certain none of the solution has stuck to the equipment and that all solution has been transferred to the standard flask. Carefully add enough distilled water to the standard flask to reach just below the calibration mark. Add the last few drops of distilled water with the dropper until the lower level of the meniscus just touches the mark on the standard flask. Stopper the standard flask and shake gently to make the solution uniform throughout. The molarity of prepared solution of oxalic acid is 0.1 molar. Determination of concentration of potassium permanganate using standard solution of oxalic acid. Take the burette, rinse it with distilled water and drain the water. Repeat this process 2 or 3 times to drain out the impurities from the burette. Then pour a small volume of potassium permanganate solution into the burette through the funnel, rinse the burette and drain out the solution. Repeat this process 2 or 3 times to remove any moisture inside the burette. Use the funnel to fill the burette with potassium permanganate solution to just above the 0 mark. Take the beaker and place it below the burette and slowly open the stopcock so that potassium permanganate is allowed to run out into the beaker and set the initial burette reading as 0. Clamp the burette vertically in the burette stand. Take the 20 ml pipette, pipette out a small volume of distilled water, rinse it and drain the water. Repeat this process 2 or 3 times to remove the impurities from the pipette. After rinsing with water, pipette out a small volume of oxalic acid solution, rinse the pipette and drain it. Repeat the step 2 or 3 times to remove any moisture inside the pipette. Now pipette out the oxalic acid solution from the standard flask until the solution level is just above the calibration mark on the pipette. Close the upper end of the pipette with the index finger. Slowly release the finger so that the solution is allowed to run slowly until the lower edge of the meniscus just touches the mark on the pipette, so that the volume of the solution becomes 20 ml. Carefully transfer the 20 ml oxalic acid solution into the clean conical flask. Touch the tip of the pipette with the bottom of the conical flask to transfer the remaining solution from the pipette. Now add about 20 ml, which is the test tube full of dilute sulfuric acid, to the oxalic acid solution in the conical flask. Place the flask over the hot plate and heat the contents of the conical flask to 60 to 70 degrees Celsius as the reaction takes place at a higher temperature. Place the conical flask on the white surface of the stand under the burette to correctly view the color change. Run potassium permanganate solution dropwise from the burette into the conical flask with constant shaking of the solution in the conical flask. Continue till the color of the solution changes from colorless to light pink on addition of the last single drop of potassium permanganate. This is called the end point. Note down the final burette reading and repeat the same procedure until concordant values are obtained. Record the observations in the tabular column. Calculations. Volume of oxalic acid is equal to 20 ml. Molarity of oxalic acid is equal to 0.1 molar. Volume of potassium permanganate solution is equal to 16 ml. From the reaction between the oxalic acid and potassium permanganate, it is clear that 2 moles of potassium permanganate reacts with 5 moles of oxalic acid. According to the molarity equation, volume of potassium permanganate into molarity of potassium permanganate divided by volume of oxalic acid into molarity of oxalic acid is equal to number of moles of potassium permanganate divided by number of moles of oxalic acid. That is, 16 into molarity of potassium permanganate divided by 20 into 0.1 is equal to 2 by 5. Therefore, molarity of the given potassium permanganate solution is equal to 20 into 0.1 into 2 divided by 16 into 5, which is equal to 0.05 molar. Molar mass of potassium permanganate is equal to 158 grams per mole. Therefore, the strength of the given potassium permanganate solution is equal to molarity of potassium permanganate into molar mass of potassium permanganate is equal to 0.05 into 158 is equal to 7.9 grams per liter. Precautions. Always keep the lower end of the pipette in the liquid when sucking it. Carefully fill the burette with the solution and see that the stopcock does not leak. Read the upper meniscus while taking burette reading with potassium permanganate solution. No drops of solution should be at the tip of the burette at the end point. Rotate the titration flask throughout the titration to ensure the uniform distribution of potassium permanganate solution. During titration, operate the stopcock with the left hand and constantly swirl the flask with the right hand.